Hi everyone, I'm just making this video just for you for your exam 1 review. Alright, hope you will make use of this video and do your exams pretty well. Well, the first thing that you need to know is about some of the prefixes that I've taught. I've taught you some prefixes. So first of all, I have told you that physical quantities can be the basic type and the derived type. You must clearly know that the basic type physical quantities are mass, length, time, quantity of substance, and electric current, temperature, these are the basic quantities. These are quantities. Now what are the units? Units for this is kilograms, meters, seconds, mole, ampere, and Kelvin. So you should clearly differentiate between physical quantities, basic physical quantities, and basic units. And all others units and quantities are derived, like speed, velocity, acceleration. They're all derived. So understand that concept. Okay. The other thing you should know is the prefixes. I've shown you so many prefixes like meter, then kilometer, then megameter, then gigameter, and on the lower side decimeter, centimeter, millimeter, micrometer, nanometer. Goes on like this. Now what is deci? Deci is 10 to the power of -1. Centi is 10 to the power of -2. Milli is 10 to the power of -3. Micro is 10 power -6. Nano is 10 power -9. And going the other way around, this is 10 power 3. This is 10 power 6. And this is 10 power 9. Okay. So if I ask you 55 milliseconds, how many seconds is that? So 55 milliseconds is how many seconds? So what you do is write the milli. Where is the milli? Milli is 10 power -3. So write 55 times 10 to the power of -3. Now you can plug this into the calculator straight away, or what you can do is, can you see this 3 here? 3 minus 3 implies you're going backward. So write 55, and from this side you go backward 3 times. 1, 2, and jump around that. So you get here. So that is the answer. 0.055 seconds. Another example will be, let's say 30 microampere is how many amperes? So what do you do? This is 30 times 10 to the power of -6 ampere. So what do you write is 30 first. Put a bunch of zeros because you're going backward. And then start from here, go back 6 times. 1, 2, 3, 4, 5, 6. So right there, the decimal. So you have 0.00030. That will be the answer in amperes. Or you can just simply plug this into the calculator, and whatever the calculator gives out, that should be the answer. So you can do it either way. Alright, so this is something that you should know. The other thing is about the graphs that I've given you. Remember, I've given you displacement time graphs. Displacement time graphs. And I also gave you distance time graph. If you look back at your notes, you'll find that distance time graph. So if you have a line like this, what does it mean? That means the distance is increasing in a steady manner. This is speed. So slope of this line gets you speed. So what is the slope of distance time graph? Speed. What's the slope of displacement time graph? Is velocity. See, the difference between speed and velocity is between displacement and distance. So slope of this graph is going to be velocity. Now, if a line is flat like that, that means the slope is 0, which means this is 0 velocity. This means 0 velocity, not moving. Now, if a line is going like this, that means it is negative velocity. So that's a negative velocity because its slope is negative. Flat, 0 velocity. This, positive velocity. This, negative velocity. All right? So, and the steeper. So what about this one? This means it's moving faster. That means the speed is more. This speed is more. This one speed is less. This one is 0 speed. So slope will tell you whether it is going faster or slower. Now this means it is going backward. Now this means if it is going backward quickly, because in very little time it is coming down. So understand that the slope has great meaning. Okay. Now when the velocity is 0, what's the acceleration? 0. Now this is constant velocity. Constant velocity means what is the acceleration? 0. If you want to show acceleration on a displacement time graph, the graph should not go straight, it should go like that. This is actually accelerating. Okay, so if you have a straight line, the acceleration is 0. But you have a curve like this on a displacement time graph, the acceleration is existing. So this one, no acceleration. This one, no acceleration. So you should be able to recognize where it is moving and where it is not moving. Okay, so that is something you should be aware of. Then if you have a velocity time graph, if a line is horizontal, that means it is constant velocity. If a line is going like this, it means it is accelerating, and it's uniform acceleration. So this means constant acceleration. This means no acceleration. So constant velocity. This is uniform acceleration. So the slope of velocity time graph gives you what? Slope of velocity time graph gives acceleration. Okay, is that clear? Okay, the next thing what I have on my list is this, the Newton's laws. Okay, so remember Newton's laws 1, 2 and 3. The first law says any object will stay in the same state of motion unless acted on by external unbalanced forces. Second law says that the net force is equal to mass times acceleration. Right? So if there is a net force acting on an object, then it is going to accelerate. The third one says for every action there is an equal and opposite reaction. That means you push on something, that object pushes you back. So if this is a table and you're pushing the table, if you push the table will push you back. And the amount of push that you apply and the amount of push that the table applies on you, they are exactly the same. So Newton's third law basically is that now that's a truck and that is a car. Bad car. All right, so you have a car and you have a truck. Now if they come and hit each other, which one exerts more force? The truck on the car or the car on the truck? They both apply the same force. Okay, so remember that concept. The truck pushes the car as much as how much the car pushes the truck. That is Newton's third law. So even if the car is dragged that way, still the car applies the same force on the truck as the truck applies on the car. Okay, so if you focus on that, that's a very important thing. The Newton's third law says action reaction are always equal and opposite. Okay, and then if you remember, I went through equations of motion. Now the equations of motion, you must be able to write it down on a note card, or you can write it down in your notes because we'll be using it, so you can actually have a note card. So equations of motion are this: velocity final is velocity initial plus acceleration times time. Displacement is equal to initial velocity times time plus half times at squared, and displacement also is Vf plus Vi over 2 times time. So you may need all these equations, and then we have Vf square is equal to Vi square plus 2ax. So you can write these equations down. Now there are 5 variables: Vi, Vf, acceleration, displacement, and time. Out of these 5 variables, you will be given 3 variables, and you will be asked one other variable. One variable's information will not be available at all, which means what you do is you pick the equation that does not have that variable. That's how you work problems out. So if you're given Vi, you're given Vf, you're given acceleration, you are asked for displacement, and time is not mentioned in the problem at all, then you have to pick an equation which does not have time. This one has time, this one has time, this one has time, this doesn't have time. So we pick that equation. Okay, for example, if I tell you a car starts from rest, so starts from rest means initial velocity is 0, and then if it is accelerating at 4 meters per second square, and if I'm telling also that the car does like this for 3 seconds, and the question is, what is the velocity with which it's going here? So if you want to find out that, what you do is check the list. You have initial velocity, you have acceleration, you have time, you have 3 things already, and what is required is Vf. Now what is the thing that is not given to you here? Out of these 5 variables, you can see x is not given to you. So when x is not given to you, you go and pick an equation which does not have x. This has x, this has x, this has x, that one doesn't have x. So you pick that equation. So Vf is equals to Vi plus At, and just plug in. This is 0 plus acceleration is 4 times time is 3. So your answer is 4 times 3, which is 12 meters per second. That's the final velocity. Now if the question was not asking that, instead if the question was asking how far does it move, if it is moving from 0 speed for 3 seconds, how much distance did it cover? So then what you have to do is, okay, the question is asking for distance covered. So what you do is initial velocity is 0, acceleration is 4, time is 3. Now you want how far. What is not here? Final velocity is not there. So what do? You pick an equation where final velocity is not there, which is the second equation. So you write down the equation: x is equal to Vit plus half At square. So you want x. Vit is 0 because Vi is 0, plus half A t square, 3 square. So this becomes half of 4 is 2 times 3 square is 9. So the answer is 18 meters. So The car must have moved 18 meters in 3 seconds. Hope that is clear. Okay. So any problem related to these quantities, list them, pick the correct equation, and go on. I can give you another question. Let's say a car starts from rest. A car starts from rest, and after 5 seconds, the car has gone 60 meters in 5 seconds. It starts from rest. The question is, what is the acceleration? So what you have to do over here is your initial velocity is 0, displacement is 60, time is 5. Now you need acceleration. What is the thing that is not mentioned here? Final velocity. So final velocity is not there, so go and pick that equation which does not have final velocity. So your equation is x is equal to VIT plus half a t square. So substitute 60 is equal to, this is 0 because 0, plus half a t square. T is 5, so 5 squared. Now if you simplify it, you get 60 is equal to 5 squared is 25. 25 divided by 2 is 12.5. So you'll get 12.5a. Then how do you get a? Divide both sides with 12.5. So you have, when you divide both sides by 12.5, you get 60 divided by 12.5. Okay, so 60 divided by 12.5 is 4.8 meters per second square. That is your acceleration. 60 divided by 12.5 is yes. Okay, so that is your acceleration. Hope you get that clear. So all the equations, you should be able to work with this concept. All right, so let's see. The other thing is, if you're asked, for example, if the mass is given to you, so imagine the car has a mass of 1000 kg and it starts from rest. And if it is told to you that it goes up to a speed of, final speed of 10 meters per second in 4 seconds. The question is, what is the force that is pushing it? Question is asking for force, but force is mass times acceleration. So if you can get the acceleration, because mass is given to you here, you can use the mass and acceleration and find the force. Okay, so let's find the acceleration. So to find the acceleration, go as usual. Initial velocity is 0, time is 4 seconds, final velocity is given, acceleration is what? Now what is not there here? The displacement is not there. So the equation which does not have displacement is this. So just write it down and put all those things down. 10 is equal to VI 0 plus acceleration times 4. So 10 is equal to 4a. So a is 10 divided by 4, which is 2.5 meters per second squared. So once you have the acceleration, plug it there. So we have F is equal to ma. M is 1000. So we have 1000 times 2.5, and the answer is 2,500 newtons. So the force that drives it, the force that drives this forward is 2,500 newtons. You saw how this thing is done? You should be able to solve in this manner. Okay. Then I discussed some examples of energy. Energy can be different types. You have kinetic energy, which is due to motion. Potential energy is due to position. So this is due to position. This is kinetic energy is due to motion. So if there is any energy related to position, like position of a spring or water, in the tank, those things are all potential energy. Whereas if something is moving, then it has kinetic energy. A moving car has kinetic energy. Okay, wind has kinetic energy. So you should be able to differentiate between where is the potential energy and what do you mean by potential energy and kinetic energy. Another example, another question is about centripetal acceleration. Centripetal acceleration. You know the formula for centripetal acceleration is v squared over r. So you must be able to work calculations based on that. You must have seen such questions in the homework. So if a car is taking a turn of such radius with a certain speed, all you do is just plug the velocity there, plug the radius there. You should be able to find the centripetal acceleration with that formula. Okay. Then okay, let me see. Okay. If you're given, suppose a force is given to you. Suppose you apply a force on an object and you push that object for a period of time, and you must have already got that information that force times time is equal to the change in momentum, and this quantity is called impulse. So if you're given force and time, you can just multiply force and time and that will give the change in momentum. You can also multiply force and time and that will be the impulse. So if you're asked impulse or change in momentum, it is basically the same thing. So understand, change in momentum. Momentum is given by mass times velocity. And the unit of momentum is kilogram for mass, velocity is meters per second. So if you're asked change in momentum, then the unit is going to be that. But if you're asked impulse, the unit is going to be, for force it's Newton, for time it's going to be seconds, so it'll be Newton second. So this is impulse and that is momentum. Okay, so but the point that is to be noted over here is this: the impulse that you apply on an object produces a change in momentum. So if I give you the force is 500 newtons applied for 10 seconds, how much is the change in momentum? The change in momentum is going to be the same as this. So 500 times 10, which is 5,000 newton second. And how much is the change in momentum? It's the same thing, 5,000 kilogram meter per second. So understand that concept of change in momentums. Okay. Now centripetal acceleration we saw. What is centripetal force? Centripetal force is mass times that acceleration. So v square over r. So this is centripetal force. Centripetal force, that's centripetal acceleration. So if you're told that you have, let's say you have a string that you tied an object here of a certain mass, and you tie it on a string, and you just keep whirling the string round and round. And the question is, okay, the string's length is given to you. See, that's the radius. String length is given to you. So if the string is going round and round, what is the centripetal force? Now, where is the centripetal force? Where's the force that keeps this object going round and round? It is the tension. The tension in the cable, the tension in the cord is the centripetal force. So this is the centripetal force. Centripetal force is mv square over r. So m is here, radius is here, v is how fast it is spinning. So you can actually find the centripetal force. And where is the centripetal force seen in this particular problem? It is the tension in the cable. Okay, that's some information that you should be having. All right, and then I told you about potential energy, gravitational potential energy. The formula is mass times gravity times height. So if you're actually moving, if this is the mass, mass times gravity is weight. So weight times height. Weight times height gives you GPE, gravitational potential energy. So if I tell you the mass is this and you're taking it to a height of h, then what you do is just put m times g times h. M is the mass in kilograms, g is 9.8, and h is the height you're taking up through. Now instead, if I give you the weight, and if I'm telling you to take it to a height of h, then you just multiply weight and height, and you get the same thing as gravitational potential energy. For example, if I told you the weight of an object is 500 newtons, and if I'm taking that object up to a height of 2 meters, so how much is the GPE of this object? How much is the gravitational potential energy of this object sitting over here? It is weight times the height you're taking. So it is going to be GPE is going to be 500 times 2, which is 1000 joules. Energy is measured in joules. All right, so suppose you know that part of it. And now if I lifted this from here to here in a time, let's say in a time of 5 seconds. So if I lift it from here to here in a time of 5 seconds, so what is power? Power is the energy over time. And how much energy did I spend to take it up from here to here? I spent 1000 joules. So 1000 divided by how much time? Let's say I did it in 5 seconds. So 5 seconds. So that's going to be 200 joule per second. Joule per second is watt. Okay. So make sure you are clear with that information. The other thing is frequency is 1 over time period. Frequency is the reciprocal of time period. So what is frequency? Frequency is the number of times something happens per second. And time period is the time taken for that happening. All right? So for example, if a pendulum is swinging back and forth, if the pendulum is swinging back and forth with a time period of 2 seconds, if the time period is 2 seconds, how much is the frequency? So all you do is frequency is 1 over time period. and I told you the time period is 2 seconds, so frequency is equal to 1 over 2, which is 0.5, and frequency's unit is hertz. You can write it as hertz, or you can write it as per second, or you can write it as 0.5 second to the power of minus 1. So you can write any of this. Okay. So understand that concept. All right. The next concept is something that I've explained in class. For example, a roller coaster. The roller coaster is here. And if the roller coaster is here, let's say it has energy of 10,000 joules. And if it goes all the way from here to here, what is happening is, what kind of energy is this? This is gravitational potential energy. Now, if this is moving from here to here, rolling down all the way and coming here, it is losing the GPE, but it is going to be converted into 10,000 joules of kinetic energy. So the kinetic energy at this point is going to be 10,000 joules. Now what is the kinetic energy here on the top? Kinetic energy is 0. What is the potential energy at the bottom? That is 0. So at the top, it stores the energy as potential energy. Kinetic energy is not there because it's just beginning to go. At the bottom here, all the kinetic and all the potential energy is transferred into kinetic energy. So the potential energy is completely 0. Now, if it comes down a bit, and suppose I tell you that the potential energy over here is 8,000 joules. So how much should be the kinetic energy? How much will be the kinetic energy? If I tell you the potential energy is 8,000, it was 10,000 here, now it's only 8,000. The kinetic energy is going to be the remainder, which is 2,000 joules. That means it is moving to some extent. So energy is conserved. When you add these two, it should come to the same thing. So energy is conserved. All right? And that is one concept. The other thing is work. So work is force times displacement. So I told you this, that when you apply a force in the vertical direction and then drag it sideways, no work done. But when you apply a force in that direction and then drag it in the same direction, then work is done. Okay, so that concept should be known. And then the concept that you need to know for the test is about collisions. What is conserved in collisions? So when objects collide with each other, there are different kinds of collisions. We have elastic, you have inelastic, and inelastic is two types, just inelastic and perfectly inelastic. So in all collisions, momentum is conserved. In all collisions, momentum should be conserved. But the kinetic energy is conserved in which of the collisions? Only here, kinetic energy is conserved. And none of this kinetic energy is conserved. That means there is loss of kinetic energy when collisions are of this type. There is a loss of kinetic energy. Here, kinetic energy is the same before and after the collision. Here, the kinetic energy after the collision will be smaller than the kinetic energy before the collision. And perfectly inelastic means they're sticking together after the impact. So you should be aware of that. The other concepts is about the gravitational force, right? The force of gravity. You should be able to work on those things. Remember, I gave you the examples, like you're standing on the earth. So when you're standing on the earth, that's the earth. You're standing on the earth, your weight is something, because the distance from here to here is 4,000 miles. So if you're standing here, you weigh a certain amount. Let's say you weigh 900 pounds. Oh no, that'll be a lot. So let's say you weigh 180 pounds. So if you're weighing 180 pounds over here, what will happen if you go exactly the same distance up, 4,000 more miles up? When you go there, the force drops. So gravitational force, which is a weight, is proportional to the product of the masses and inversely proportional to the distance square. So this is the most important point here, the distance square. That means when you're at a distance of 4,000 miles, you had a certain force, which is this. But when you double the distance from here to here, the distance is now doubled. When you double the distance, because there's a squaring aspect, when you double the distance, the 2 of the double also getting squared. So you will have a factor of 4 coming in the denominator. So what I mean to say is this: instead of d, if it becomes 2d, when you square the 2d, you get 4d square. So imagine 4d square comes in place of that. There's an extra 4 sitting here. That means the gravitational force drops by 4 times. So at this point, the gravitational force is going to be smaller because you're going away from the earth. How many times smaller? 4 times smaller. 4 times smaller than this is 45 pounds. Now what if you go further? Another 4,000 miles. So now the total distance is like tripled. So when you triple it, 3d square makes it 9d square. So the factor of 9 at the bottom here makes the gravitational force go down by 9 times. If it goes down 9 times, what will be the new force on the top here? It will be 20 pounds. So if you go 8,000 miles from the surface of the earth, you will weigh only 20 pounds. Okay, so the further away you go, the force drops. So that's an important concept that you should be knowing. And then I gave you some problems of remember the collisions, the car coming in this direction and that car is coming in that direction, and they come and collide. I have worked out those questions in class, and you should be able to work them out exactly similar. So for example, if I put this as 10 kilograms moving at 3 meters per second, and then this one is 7 kilograms and moving at 5 meters per second. So this is going to the right and that's going to the left. After the collision, imagine both of them join together. Which way will they go? So what do you do? Find the momentum of this first, which is 30 to the right. So it's positive 30. And what is the momentum of this? It's 7 times 5, but it's backward. So it's minus 35. So what is the total momentum? The total momentum is going to be 30 minus 35, which is minus 5. Now the total momentum of this after the impact should be the same as this. So the total mass is going to be 10 plus 7, 17 kilograms. So 17 kilograms, and it's moving with some speed we don't know. So how do you do it? 17v, 17 times how fast it's going, should be equal to minus 5. So v will be minus 5 over 17. So it will be a negative answer, negative approximately 3, negative 3 meters per second. Now what does the negative sign tell you? Negative sign tells you that it's going backward to the left, and 3 tells you how fast it is moving. Oh, sorry, it's not 3, it's 0.3. It is 0.3. Okay, so it is moving to the left at 0.3 meters per second. Okay, so that is a concept that you should be having, and pretty much it. So you should be pretty good with this. Go back again to the video from the beginning and try to understand all the different areas that I've touched up. Go back into your notes and find out what I've said in class about those, like these kind of questions. Make sure that you know exactly how to get there, and then you should be in a position to do the test well. All right, all the best to you. Good luck.